Here today we will see about hybrid energy storage systems for electric vehicle applications. Here we are using two energy storage systems. One is battery and one is supercapacitor. When the battery is not available, at the time the supercapacitor will provide the energy to the DC motor through a bidirectional buck boost converter. And the DC motor will be powered using the buck converter. And also I have provided one condition. If the battery state of charge is less than 10%, then the battery and the ultra capacitor will be providing the supply. Here the battery voltage is 48 volt and initial state of charge I have provided as 10.0006%, and capacity of the battery is 7.5 Ah. And this is super capacitor. Capacitance value 100 farad. Rated voltage is 24 volt. That is connected to the DC motor of speed 1500 RPM and voltage 24 volt. And this one is speed control loop. Here I have changed the reference speed from 100 radian per second to 50 radian per second at 0.5 seconds. That is compared with measured speed, and error is given to PI controller. The PI controller will generate DC voltage reference, that is buck converter output voltage, and that is compared with the measured DC output voltage. Error is given to PI controller. The PI controller will generate duty ratio, which will be compared with high frequency carrier waveform. Here the frequency is 5 kilohertz. And from that comparison, we will get the pulses. That pulses will be given to the buck converter only if the torque is positive. That means here, yeah, torque is positive. That means when we apply regenerative braking, then the pulses for buck converter will be stopped because the energy from the motor windings will be fed back to the ultra capacitor. Okay, for torque also initially we have provided 0.1 Newton meter. At 0.8 second, it is changed to 1 Newton meter. So we have changed the speed from 100 to 50 at 0.5 seconds, and we have changed the torque, mechanical torque or load torque from 0.1 Newton meter to 1 Newton meter at 0.8 seconds. And after 1.5 seconds, 1.3 seconds, we are applying the braking. So this is the motor speed. Okay, initially it is 100 radian per second. After 0.5 seconds, when the reference speed changes, the measured speed also changed here, 50 radian per second. And at 0.8 second, we have increased the load. So when load is increased, the speed is slightly oscillating. At 1.3 seconds, we applied the braking, so the speed goes to 0. Similarly, voltage and current. Initially, the voltage is around 16 volt. And when the speed is reduced at 0.5 seconds, it is reaching nearly 9 volt. And when the torque is increased, the voltage slightly increased to 12 volt. Similarly, the current is nearly 0.5 amps. And at 0.8 second, when the torque is, that is load is increased, the current is increased to 8 amps. Power also it is changed. Initially it is around 12 watts. Then at 0.8 second it is reached to 100 watts. And here this is the state of charge for the battery. From 10.0006 percentage it is decreasing, and once it reached 10 percentage the battery is disconnected, so the SOC is same constant throughout the time. And this is ultra capacitor. Initial state of charge is around 91.38 percentage, and when the battery is disconnected the ultra capacitor starts providing the energy, so the state of charge here decreases until 1.3 second. After that, when braking, regenerative braking is applied, here the state of charge is increased because the ultra capacitor is charging during this time period from the energy from motor windings. Why we are doing this means by charging the ultra capacitor, we can able to extend the running time of the vehicle. Whenever braking is applied, some amount of energy will be fed back to the sources. So the sources can able to provide supply for slightly longer time than the normal. And by having two energy storage systems, if one energy storage system is depleted, then next one will be providing the energy. Okay, this is the working of the hybrid energy storage system in an electric vehicle application.